trigonometric. I will start with the inverse of trigonometric functions, and since we also have done this in calculus class, so I would like to just overview what we are having. So for example, the first one is the inverse sine function. As you can see, if we are going to using all the graphs in sine, we know that if we take the horizontal line, this is going to be not one-to-one function, right? So we have to restrict the domain, and we say that we restrict the domain on this negative pi over 2 and pi over 2. And since we restricted on this domain, we have one-to-one functions. And I hope you still remember what's one-to-one function. Basically, whenever you take the horizontal line, and you only have like exactly 1 point on that line, that's one-to-one function. And then you take the inverse, basically from this part, you're changing to this. So the domain becomes range, range becomes domain. So this will be the sine inverse. So this will be all the related content for the sine inverse. Remember, when we take the inverse, and remember this -1 is not reciprocal. So it's not 1 over sine. Okay? Sometimes students make that mistake over and over again every year. So this is arc sine or sine inverse. Okay? So sine inverse means that this y is actually an angle. Okay? An angle. So we could have this property which would say sine y is equal to x. Okay? So that's sine, and the same thing happened with the cosine. So cosine, cosine is we shifted the sine. Okay? We shifted the sine pi over 2, right? And we start from when angle is 0, it starts from 1, and then until pi, we have -1. And we restrict it from the 0 to pi for the cosine. And then we take the inverse, and we have this. Okay? And the same thing with the sine, we have the cosine inverse x equal y. We could, based on the property of inverse, we can have this cosine y equal x. And again, the y indicating that this is an angle, okay, to make it simplified. Okay, so sine inverse, cosine inverse, and then the last one, the tangent inverse. Or if you would like to make the other part like a cosecant, secant, they are the same or similar with the sine, cosine, and the tangent. Okay? So we have a tangent, and if you are not really familiar with the tangent, this is how it looks like. We have several asymptotes over the period of the pi over 2. So every pi over 2, or negative pi over 2, and then take one period, so 3 over 2 pi, and then take one period, you will see the asymptote. Okay? And of course, because of the asymptote, we can restrict easily the tangent from negative pi over 2 up to pi over 2, and we can make our inverse. Okay? We can make our inverse. We switch the domain and range. Okay? And similarly, we can have this property as well. Okay? Okay. So this is something that you need to know, like, you need to know, like, you need to be familiar with this, the inverse. And then another note that I would like to have is we can write, for example, sine, and then we have the cosine inverse x, and the other part is tangent and the cosine inverse x. If you would like to express this two expressions as algebraic expression, what is algebraic expression? Algebraic expression is we need to refer this to with x. Okay? Are you able to do that? Or do you still remember how? The easiest way how to do that? Not sure, right? So what I mean is we have sine and then cosine inverse x. Okay? So can we make something from this expression and write in terms of x only? and removing all the trigonometric parts. That's what the equation means. Anyone remember how to do that?
So it's equal to sine of sine, inverse sine,
Yes.
pi over 2 plus x.
Yeah. Remove this trigonometric part. Can you remove?
So it becomes pi over 2 plus x.
But I think not complete yet. So what I mean by that is so for the sine, let me write here, cosine inverse x. So if we let's say the inside the sine, there will be an angle theta. Okay, so an angle with any variable actually. Let's say we have the theta equal cosine inverse x, which means that this will be x is cosine theta, correct? Right? Okay, we can make this definition ourselves, right? And then we could imagine that we have that, let's say the theta is going to be here, okay? So this will be x, okay? And this will be 1, right? And this will be square root 1 minus x squared, okay? This is similar with what we have done in the, I think, when we derive this in calculus, okay? So what's next? So basically, this telling you that this is sine theta. So which means that this will be equal to this over this, right? So we can write that as an algebraic expression. So sine cosine inverse x is equal, let me just write 1 like that, and equal to 1. Okay. Okay. So that is what it means by taking algebraic expression. And for the second part, the tangent, we are going to do the same thing. We can let that theta equal cosine inverse x. But since this is the same, so we can just take the tangent, and the tangent will be this over this, right? Okay. So tangent and that's what we have. So I will spend maybe 30 minutes, around 30 minutes to 40 minutes, preparing some parts of the trigonometric, and then especially the identity for the trigonometry. Okay, so that's the writing the inverse of trigonometric as algebraic expressions. Okay, now I would like to go for another part that is somewhat important in trigonometry, which is the law of sines. So in triangle, we have this law, which we call the law of sine. So anyone still remember this expression? So what does that mean is basically if we have a triangle, let's say ABC, and then we know each angle within the point. For example, this A B, C, and we know the sides, like the sides A, B, C, small letter, we can make this ratio and we call this the law of sine. Basically how to prove this is quite intuitive. If you see from this triangle, let's say this is the height h. Okay? The height h, if we take an angle from here and take this b, then sine c is basically this part h over b, or you can write h as b sine c. Right? So if this is c, this is a, this is b. And we could do the same thing with all other angles. For example, we take the dot line here, we take this line here, and we can have every angle. Okay. So let's say we have here, and then we have another one here. Okay. So if we write down the formula for the area of the triangle, so let's say area of the triangle ABC, we can write as first half B sine C multiplied by A, or let me write A in the front. Okay, this is the area. We can also write the area in terms of this height and this B. We can also do the same thing with this height and this. Okay, this will be B sine C sine A and B, and A sine B. So we can have the other part as well. Now from here, we could multiply with, so multiply by 2 over ABC. Then we could get all, so sine A over A, sine B over B. So by taking the area of the triangle, we can have this expression. So very intuitive. And whenever we see a triangle and then we're missing out some angle or some sides, we can try this ratio. There are some notes, however, but I don't think that is important. So at least the general rule for law of sine, this is how it is. Okay.
Sorry, I have my very bad load last week.
Okay, so that's law of sine, and then the other is its counterpart, which is the law of cosine. So law of cosine is basically, if we have a triangle like this, the same triangle as before, with angle A, B, C, and then we have the sides. So to make it easier, the sides in front of that angle will be its counterpart. For example, we have angle A, capital A. The side that is in front of this angle, which is this side, will be this small a. And this B, capital B, the front of this angle will be this one, small letter B. And the same thing with C. Okay. to make it the structure easy to follow. Okay. And then we have this three different formula. And if you see the formula, it's actually quite, you can see some pattern on that formula. It's a squared, and then b squared plus c squared. These are all the signs. Okay? So a squared equal b squared plus c squared minus 2bc. So the bc is going to be carried over here, and then multiplied with the cosine angle in front of this small a, which is a, the capital A. And same thing with the b squared. It's a squared plus c squared minus 2ac cosine b. Okay? So it has all the pattern. So I would like you to see how we can get this. So basically, if we have this triangle here, and then let's say if we identify this side here and this side here, and decide that we have a the angle is we call the angle here greater than 90. Or we call this angle obtuse angle. If you, I will maybe I'll talk about that later. We have obtuse, acute, reflex. If you are not really familiar with the angle, so this is called the obtuse angle, which is angle between 90 and 180. Okay. So we have A here, and then we can take this and this part using the angle from this part. So this is, we call it B cosine A, B is the hypotenuse, and this one is B sine A. So this is A, this is also A. We can say A, or 180 minus A. Okay, so from here, let me write to help see. This is B cos A. This is B. Oh wait, it's wrong. This is sine. Okay. And then by taking the Pythagorean formula from this, and then this, and this, we get that the a squared is so this will be b cosine A, and then we move here because it's positive negative, we take minus c, okay, and then plus b sine A squared. Okay. And now we take the expansion. So here's why we have the 2bc or 2ac comes. This is from the expansion. And then by the identity from the sine squared and cosine squared, we have 1 over there. So we have b squared plus c squared minus 2bc cosine A, and this will be a squared. And the rest will be similar. We have the b squared, and we have the c squared, and we have that pattern. Okay? Actually, for this one, it could be written like c minus b cosine A, same expansion. Okay, that's a law of cosine. And I think we are going to have more understanding when we have the tutorial. Okay. Yeah.
Mau tanya,
Yes.
ini diupload gak ini?
Yeah.
Ini diupload kan? Saya mau makanan, belum makan soalnya.
Oh yeah, yeah. Okay.
Oh ya.
Okay, now next thing is, I think I have mentioned about this a little bit on the Saturday class. So there are some identity that you might need in the future, but I think for like some of them you know, right, or not. Like for example, cosecant is 1/sine. I think you know, or not. If not, then that is 1/sine. And 1/cosine will be the secant. So whenever you have a secant something, you have 1/cosine. And for tangent, we have cotangent. So 1/tangent will be cotangent. Okay. And of course, tangent is sine over cos, right? This should be familiar with. And we have the Pythagorean identity, sine squared, cosine squared equal 1. And perhaps, let me check which part that we are not yet. And then from the Pythagorean, we have the tangent squared plus 1 equals secant squared. I think the third one here is not really particularly used much in use. Okay, so only these two usually, even for calculus and other mathematics course, we only rely on these two. And even odd identities, we have sine a of x minus sine x, cosine minus x is cosine x. So, do you know why? Why does it become negative? Any arguments? Yeah. We have basically, if you are getting confused on understanding the positive and negative parts on the trigonometric, usually you only having like 4 spaces in the trigonometric. So we call this the quadrants. And the space is called the quadrants. So we start from quadrant 1, quadrant 2, 3, 4. What's the difference? The difference is the rotation or the angle of the rotation. We always start from we call this the polar axis. Okay, we start from here. And we move one by one. So if we say we increase the angle, let's say pi over 4. So we move pi over 4 over there. Okay? We are increasing the angle. We increase, positive. If we move clockwise, so we are going down here, we are reducing the angle. We are decreasing the angle. Okay? So if we are moving down, so we are minusing something. So if this is in the quadrant 4, so this is negative, right? Which means that if we're talking about sine of minus x, we are talking about the quadrant 4. Now, we need to determine which one is positive, which one is negative, right? So I think everyone agree the first one, all positive, right? Okay, so let's just write all positive. This is all positive, right? And then we move here, the second quadrant. So if I'm trying to make out a triangle like this, okay? Let's say this is y, this is x, and this is our r. Okay? And let's say we have a theta here. Okay? So this is theta. So what is y? This will be r sine or cosine. Wow, taking so long. Sine. Okay. Agree? Agree or still confusing? I think in physics you should have, right? Every time you have like a force. Which one is this? If this is a force, this is an angle. Is this sine or this is cosine?
But you,
Right?
you all felt physics.
Oh, that's why. You OMG, that is very fundamental. Okay? So if you are not able to break down the force between x and y axis, you will be in so much trouble. Right? Okay, so this will be r sine theta. Or let me write. Sine theta is y over r, right? So y is r sine theta. Okay? And same thing with x. This will be r cosine theta. Okay? I would just to focus here. Okay? So this point here, of course, in x, y, this is all positive, right? If we move here, which one is negative, x or y? X. What is x? Cosine. So cosine is negative, sine is positive. How about tangent?
Negative.
Negative. Okay? So only sine is positive. Sine is positive. And then we move to this third quadrant. Which one is negative, x or y?
Both.
Both, right? So sine is negative using that equation. Cosine is negative. How about tangent? Positive, because negative, negative, positive. Okay? So this makes sense? Makes sense, right? So this will be tangent positive. And then last quadrant, the fourth quadrant. Which one is negative? X or y? Y. Only y, right? Y is sine. So sine is negative. So cosine is positive, right? So what's the implication? What's the implication? The implication is whenever we have, for example, in sine, if we have like pi minus x, this will be equal to sine x. Okay. If that is cosine, then it will be negative cosine x. That's why. So if we have this is cosine positive, every time we have cosine negative x, it will be positive. Okay. So this makes sense, right? Okay. Interesting. Okay. So if you understand, then this will be really, really easy. Easy to follow, right? Okay. And another part that is similar to what we have is we can think this part the co-function identities. So we have a co-function identity. For example, sine pi over 2 minus x. This is equal to cosine x. This is simply, we can think that this pi over 2 minus x is like shifting our graphs. Shifting our graphs pi over 2. Okay? So we can think this as sine minus x. And then we plus the pi over 2 inside. Okay? So we have sine x. And then we change sine negative x, and then we plus pi over 2. So then what we have shifting. And the same thing with the other part. But usually the most case are these two. And since the sine and cosine, they are reflecting in secant and cosecant. Because they are also 1 over sine and 1 over cosecant. So they are the same thing. But for tangent, it has the same thing with the cotangent. Okay, but the thing that commonly we are going to encounter so much in our life, in this engineering program, will be this identity, okay? This identity. And some other criteria. But mostly this part will be carry over to your other courses as well. Okay? Okay, so next part, aside from this fundamental trigonometric identity, we have what we call the addition and subtraction formula. I think some of you are familiar with it, and maybe some of you already forget everything. So this is addition and subtraction formula. So we can have sine or cosine or tangent, and then inside of that part, we can have like two angles that we can subtract or we can add. Okay? And we can have this whole thing here. Okay? So I would like just to start. I hope I have time for this. So I would just take some time to see how we can prove this through this picture here. So suppose that we have, okay, so the whole thing, this part is s plus t. So t will be here, and s will be this one. So this from p0 to q1. So let's say that's our p. From q1 to p1 is s, and then the counterpart, this p0 to p0. This will be similar to what this one here, which is the negative x. So what do we do here? We simply take this. Remember that this point, if the radius is equal 1, okay, if radius equal 1, and we can arrange the x and y, okay, so if we can arrange this part as cosine t and y is sine t for this triangle here. Okay. So if the r is 1, so if this is a circle 1, so we can arrange the point on this q1 cosine t sine t. Okay, and then we could arrange for the other as well. So this part, the p1 is becoming x is cosine s plus t. I think not okay. And y is sine s plus t. Okay. And then the p0 is just our starting point, which is 1 and 0. Okay. xy. And this one here, the xy here is x is cosine minus s, which is cosine s, and y is sine minus s or negative sine s. Okay. Now the distance between P0, P1 and Q0, Q1 from geometric perspective, they are the same. So let's make that distance formula from this P0 to P1, okay? Using this point. So let's look at that, and let me write here the P0 P1 equal the Q0 Q1. Okay. So the distance formula, hope you still remember, is actually is using Pythagorean. So this, I'm using this triangle, okay? So this will be cosine. So P0, which is P0 is 1, right? So cosine s plus t plus or minus in distance squared, and then plus y will be sine cosine sine s plus t squared. Okay. And the Q0, Q1 will be cosine t minus cosine s and then squared plus sine t plus sine s and then squared. A little bit algebra and some expansion part, which is, I think, a little bit long. So hopefully I can do it on time. Okay, that's the first one. Let me move this a little bit to the left. Okay. Okay, so I remove the square root, okay, both of them. So this will be cosine squared t plus or minus. Okay, so I have minus cosine t cosine s. This will be sine t sine s. So 2. Okay. So negative 2 cosine t cosine s plus cosine squared s plus sine squared t. I need to write here plus 2 sine t sine s plus sine squared s. Very long. Okay, so we have cosine squared s plus t. Cosine squared s plus t is 1, right? So we can plus this 2, become 1. So we have 1 plus 1, so 2. So 2 minus 2 cosine s plus t. And similarly, we have cosine squared t and sine squared t, cosine squared s and sine squared s. So 1 and 1, so 2, right? So this will be equal to 2 minus 2 cosine t cosine s plus 2 sine t sine s. This 2 will be cancelled. And then we can also cancel this 2 with this 2 and this 2, right? So cosine s plus t is cosine t cosine s minus sine t sine s. Or, to be specific, this is similar with what we have in the formula, cosine s plus t. We write s first and then t. So there we go. We have this. And then through that method, if we change s plus t become s minus t, then all the t will be minus t minus t. And remember the identity for that part. For cosine minus t is cosine t, positive. If sine minus t, it becomes positive. So it becomes positive. Get it? So that's how we get all the formula. And then here, okay, so we have this two, at least we have this two. And how would we can take the sine? We can take the sine with this formula. So we don't need to rewrite everything from zero. So we have this sine pi over 2 minus x. This will be equal to cosine x, right? So if we have sine s plus t, then we can write the counterpart. So if we have, let me write again here. So if we have sine s plus t, this is coming from cosine pi over 2 minus s plus t. Okay? And then that part is using this one. So cosine pi over 2, which is 0, so 0, sine pi over 2, 1, and sine s plus t. Okay? So we get sine s plus t from there, and we got everything in our place here. This can be also written as cosine. If you want to make it more clear, we can also separate like that. So this will be cosine pi over 2 minus s, cosine negative t, and this will be sine, negative sine. So this will be sine s cosine t. This will be plus cosine s sine t. And then we can get everything. We can get it. To prove the last one, the tangent, we need more time, but I don't think I have now. So okay, I think I will leave this to you, and I think we can now turn on to some examples. And maybe before that, just to make sure that we are on the same page. This is the double angle formula. And identities that usually will be coming up much, especially for the sine 2x and cosine 2x, these two. And if that part related to this one, okay, to the sine squared x and the cosine squared x. Especially on integration, your calculus, okay, your calculus finals will be doomed if you don't know this part. Okay? Especially for trigonometric integral. So Like every time you learn something, like you study something, always ask yourself like which part that I'm missing out. I mean, you try to learn calculus, okay? And then you see the exam, and you feel like every exam, I don't know how to work this, and every time the question asks me, like, I don't know how to solve it. So perhaps you understand what the question means, but you don't have necessary knowledge or skills to solve like step by step. Which means that you need to observe clearly which part that you are missing. Is it the algebra part? Algebra part needs like a solving skills, which requires amount of time to learn and practice. That is something that you can control actually. If you can like put your efforts, although this is like 1 week before like final exam schedule, but hopefully this can make up for your finals. Like if you know your limitations, if you know your weaknesses, then you know how to how to level up, right? So this, I think, if you don't really like make this as your friends, then it will betray you, okay? So this will comes really like a lot. Like not only for your calculus 1, but also for calculus 2 and engineering of math. When you learn engineering of math, if you take my class, I will not give you all the integration and derivative part from calculus. That you need to think by your own self. Yes. So sometimes if you fail calculus, or even if you pass, but like with a really minimum score, you will need engineering of math, which requires knowledge from calculus. So I want you to pass, even maybe not really, if the score is not good enough. What I want you to remind is you know how to. Fundamentals as a fundamental. Okay. That's, for me, it's sufficient. Sometimes score is not representing of who you are. Okay? It's just matrix system that usually people use to measure. And sometimes it doesn't reflect your story at all, right? And you need to prove that. Like GPA, sometimes it's important, sometimes it's not much important. It depends. Depends how you reflect. Like sometimes you are, oh, my GPA is high, blah, 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 I'm the top student, blah, blah, blah. Maybe if he tried to solve some problems with his teammates, like teamwork, maybe he's not going to make it. So I want you to like reflect all the experience you have, not only for the score or GPA, but also for other things as well. Because all will make balance in your life. Okay? I'm not saying GPA is not important. You still need to pass the courses and everything. Okay. Okay. I think we can move to the tutorial part, and my goal is we can finish this around 8:20 or 8:30, okay, or maybe faster than that. Okay, we start from here. So based on what we have before, sometimes the questions is asking some part of identity or proving the identity itself, like it's giving you identity and you need to like proving that. But this one, I think just you are given information of the one part, and then you need to use identity to make a new arrangement. Okay? To make a new arrangement. So we have cosine x and we have cosine 2x. So this is a double angle situations. Anyone would like to try? I think we're missing out the groupings somehow. Yeah. Oh, by the way, since I talked before. Maybe your teammates.
I'm not sure.
Oh yeah, forget right. Yeah. Okay, that's okay. Okay. Anyway, like I give the introduction at the early classes that we might have a final exam, but maybe not in class. Okay. So it's like a final assignment. You could say that. So I will prepare. I'm still not sure which platform should I use. Usually, either I'm using the quizzes that you're familiar with in calculus, or last year I'm using a platform called FlexiQuiz. But since FlexiQuiz is actually, I need to pay for that. And now I don't want to pay again. So I think I will just using quizzes. And quizzes now has a more, I think, better UI and experience, especially for math. So I think I'm trying to use quizzes. Each question, there will be a time limit, and you need just to follow up the structure and instructions. Okay, I'm trying to perhaps preparing the questions for the whole semester, like from the early classes in our basic math until the trigonometric. You can prepare your own notes, or you can just prepare your, like if you have like a notebook, you just prepare the notebooks. You can prepare individually. What I don't want is you prepare it like with a group discussions. Usually you make a blue line group and then hey, this number, what is this, blah blah blah. I know all that stuff, and if I know something is fishy, I will, for obvious reason, I will know, and you don't like what I want to do for that. So I give you like notebooks. I hope that is okay. Okay. The questions will be average questions, like average questions, not really that difficult. Okay, maybe there will be a difficult question, but not all questions. So this will be like a typical average question for each chapter. Okay, so that will be the date. I'm not sure yet, but do you have any prescriptions? Maybe when should I give? So basically, technically, you can take like between some days, a few days. Like I give you like maybe 2 to 3 days. You can pick between those 3 days. Do you think that's okay, or I mean, you can think like which finals you are maybe more anxious about calculus, right? Or when is chemistry finals?
Monday.
Like next Monday. Like
Next week, right?
Yeah.
Oh, okay. So maybe if calculus is a Thursday,
We are going to have in Christmas.
yeah, maybe
No. No.
like Friday until before Christmas. Like
Oh,
maybe you will get a good, maybe you will get a gift.
Can it be 20?
Maybe
Free?
from Friday to
Sunday. Yeah, 3 days. Friday to Sunday.
Merry Christmas.
Next semester.
Maybe next like January.
I would like to, but hear me out. Even if I check the finals, and if the final score for each one of you, I already arranged everything. If some students might need help, you need to have additional requirements. I'm still thinking what will be, but that will be like additional like assignments. Okay. But hopefully then, but if there are some students that is like the gap is too far that I cannot help with, then I'm really sorry about that. But for students who are like, okay, this is a little bit more, and then I can just give this assignment, and that will be easily done. Okay. So yeah, but if you have like assignment like that, then you need to prepare another week to prepare that assignment. Not for all, not for all. Hopefully you are not in that group. Okay. Okay, because I checked, maybe a few of you maybe need that addition. Okay, any questions first for that part? So Friday to Sunday will be okay?
What time will be made available on Friday?
I think Friday will be available from morning. I will announce the time, and then the ending, the deadline.
Until Sunday 11.
Se hace como lo que no da final de clase.
But sometimes students think, oh, there is the time that they are going to enter, but it's actually the time for the deadline.
This Friday
Yes.
we have physics right
Yeah. Next week. But 22 to 22, 23, 24. Yeah, I mean after like that is the after finals, right? 22, 23, 24. Like you can pick which one you like.
When we take material science,
Okay. I hope everyone is okay with the dates. Okay. Although not everyone here, but I will try to announce in the Moodle. Okay.
Tenemos 3 días para hacerlo, pero no
Okay. Anyway.
calculus.
Yeah.
When's our calculus final?
I think 21 Thursday. Right?
This Thursday.
Yeah. Oh no, next week.
Okay.
We are not done yet. There is still one more section to go. Okay, now this will be given that cosine x is that, determine the cosine 2x. So we can start with the double angle formula. So double angle formula is, we start from that, right? Or directly we can write, now it's just cosine, so we can write 2 cosine squared minus 1. Okay. Do you know how I can get this? This is from, the sine is 1 minus cosine. Minus it becomes 2 cosine minus 1. Okay. It's from that. And then we can just make it true. This will be that, right? So this will be 2 so this will be 4 square root of 2, 4 plus 4 plus 2, 6 minus 1 is 5, so this is 5 minus 4 square root of 2. Okay? Okay. Easy, right? Okay. Next one is proving identity like this. Yes. Huh? This one?
Yes.
Okay.
For inner people.
Yes.
Are you gonna send this PowerPoint?
Yeah. So how to prove the identity? If you are given the whole equation like this, what you can do is you can start from the right, or you can start from the left. If you start from the right, secant, you can start with 1 over cosine 2x, and then from that you can have 1 over either cosine squared x minus sine squared x, or you can relate that and you can make some rationalizations and you can make it. Or you can start from the left, and I think it's easier from the left. You see the tangent squared? you can start from the tangent, making sine over cosine, and then solve the equation and simplify it and making it to the secant to x. So first, you can take the 1 plus, this will be sine squared x over cosine squared x. And the same thing here. And then I will multiply with 1 over cosine squared x, both of them. Or let me write, the top will be that, the bottom also that, okay? So we have, oh wait, why I'm multiplying with 1 over cosine? I'm so silly. Just cosine. So this will be cosine squared x plus sine squared x, and over cosine squared x minus sine squared x, which is, this will be 1 over, this will be cosine to x, or secant to x. You can try also from the secant to x. You can make it as 1 over cosine to x. And cosine to x, you can write like this, and 1 you can write like this, and you can split each one of them, and then if you want, you can just define like with cosine squared and make it this, so you can take reverse part of them. But I think intuitively, what I would like to suggest is start from the left, and then it's much more intuitively easier to understand the process. So if the question is just proving identity, then perhaps you just need to prove. But I think if I'm giving you the online test, maybe not like, maybe just giving you the equations and then it's equal and then give you the multiple choices. There's some multiple choices, some is filling in answers, fill the blank. Okay. Okay, now the next question is this. First asking the proof, validity, and then show the, or you would like to try this at home, this one? I would like to maybe taking the different questions. Wait. Oh, maybe this one. Reflex and obtuse. So it is given that we have sine p, that is the ratio, 8 over 17, and tangent q, 4 over q. And then we are given that the p is obtuse. Obtuse means it's, to be simplified, I have this definition. But sometimes if it is not even, it means that the obtuse will be the second quadrant, the reflex will be the fourth quadrant. If it is acute, it means the first quadrant, okay? Less than 90 degree. Yes.
So reflex be in the third and the fourth quadrant.
Yes. Oh, second and fourth.
The reflex.
The obtuse is second. Reflex is
Second and fourth.
oh yeah, third and fourth. Yeah, sorry. Yeah, third and fourth. So this will be cosine P cosine Q plus sine P sine Q, right? So we have to draw the P and Q. Too small. Let's say this is sine P. It's 15, right? Yeah, 15, right? Okay. And if we have another one, this Q is tangent 4, 3, 5, right? So what we have now? Cosine P is obtuse, so I will write obtuse. Every sign is positive. And Q is reflex, so tangent and cosine positive. So cosine P is negative 15 over 17. Cosine Q is 3 over 5. Plus 8 over 17. Sine Q is negative 4 over 5. Okay, so we have, this will be negative 9. Yeah, I'm too lazy to calculate this. So negative 77 over that 85, right? 77 over 85. Okay. So basically, what you did, what you need to do is, every time you see the, whenever it's obtuse or reflex, you need to remember which one is the positive, okay, from the sine, cosine, and tangent. Okay. So for obtuse, sine is positive. For the reflex, the cosine is positive, or and tangent. And then you just plug in all the numbers with the signs, positive or negative, and then just compute. Okay, I think very clear, right? Not really that bad, right? Okay. How about this this one? We have trigonometric equations we need to solve. So what should you do first? So basically, how to solve it is basically we need to find which x that is satisfying this equation. Okay. So first is maybe we arrange that the cosine inverse will equal to something, right? We expected pi here, right? So just move there and then divide by 3. Okay. So we can write this as cosine inverse is pi over 3. Okay, then that's the first steps. And then what should we do? We take the cosine for both sides. Okay. So cosine pi over 3 is half. So this will be x plus 1. So x will be negative 1 over 2. Okay. So remember, every time you have an inverse and you have an equation with an inverse, if there's nothing there, like you have only one inverse like this, you can add, for example, cosine inverse, just take cosine. So what we did here, we take the cosine inverse. So remember that when we have cosine inverse, this is actually the angle, right? This is actually the angle. So we can take the cosine of this angle. Okay, that's how it is. Yeah, if you understand what I mean. Because I think in your calculus quiz, I think one of the integration has a sign, and then inside the sign is another sign. Right? Some students, they make the sign and multiply with the inside, and it becomes sine squared, which is not true. Right? So yeah, I mean, you need to understand every step you take. What is that? Like, why you take that steps? Why you take that process? Okay. Okay. Anyway, let's go for I think 2 more questions. Okay. I think this is quite similar. Let me try. Which one? How about this one? What is the first step? So the first step is, you see the left part is, they are all in terms of, this is the value that we, like, it's the given value, right? This has a half, it says the tangent inverse. What we need to solve is this, right? We need to find what is x. So the best way to take this is, let's just take cosine both sides. If we take cosine here, it will be x. Right? This will be cosine with this, right? Okay, so let's just write that. And what does that mean, right? So if you take cosine over here, this will be 2. Let me write tangent inverse. Same with arctangent. And this will be x, right? Or if you want, you can write cosine and then cosine inverse x. So that will be x. And what's next? We have tangent inverse half here. What's the nature of this? That's an angle. Agree? An angle, right? So if we take this as theta to simplify our equation, we can do that. Just to let the simplification and for algebraic solving problems. So let theta equal tangent inverse half. So this will be cosine 2 theta. So we can write it here as x. And then to find, we can either try to build our triangle from the theta. So we have theta here, so which means that this tangent theta is 1/2, right? Okay. So theta is over there, so this is 1, this is 2. So this will be square root of 5, okay? So we have all the sides for the theta. Now we're going back to the cosine 2 theta. So I will write cosine 2 theta as the double angle formula that I've introduced you to before. So that we can write this will be that -1 equal to x. And cosine theta, we get from here 2 over square root of 5. Take squared, so 2 over 5. So this will be 4 over 5. So we can write this will be 2 multiply with 2 over square root of 5 squared minus 1 is x. So this is 4 over 5. So 8 over 5 minus 1. So x is 3 over 5. Okay. Okay. Any questions? Do you want to finish up? Okay. I think finish up. So I will give you all the notes, tutorial, and also announcement for your final assignments.